All right, let me stop you right there. Because if you've been scrolling through social media lately and spotted headlines screaming about Tropical Storm Arthur brewing in the Caribbean, I need you to take a breath. There is no Arthur. There never was an Arthur. No storm. No swirling monster. Nothing. Zip, the National Hurricane Center itself, the people whose entire job is watching for these things, has flat out said that tropical cyclone formation is not expected in the next 7 days. So whoever stamped Arthur across a dark, moody thunderstorm photo in big red letters and slapped it on a thumbnail, yeah, that wasn't meteorology. That was content farming. What is real, and honestly far more fascinating than a made-up storm name, is the atmospheric setup that's got the whole continent behaving like it lost track of what month it is. We're talking about something called an omega block, and once you understand what it is, every single weird weather story you've seen lately suddenly clicks into place like puzzle pieces you didn't know belong together. Before we dive in, if this kind of deep dive weather breakdown is your thing, and clearly it is, since you're still reading, go ahead and hit that like button and subscribe so you don't miss the next one. And drop a comment down below telling me where you're watching from. Seriously, I love seeing where the audience is tuning in from. Now let's get into it. Part 1. The weather balloon that shouldn't have said what it said. Early on the morning of May 27, 2026, a weather balloon drifted up into the sky from Dulles International Airport just outside Washington, D.C. Strapped to it was a little instrument package about the size of a milk carton, a radio sonde, quietly measuring temperature, humidity, pressure, and wind at every level of the atmosphere as it climbed. Now here's the thing, this is one of the most routine, almost mind-numbingly boring things that operational meteorology does. Twice a day, every single day, at airports and weather service offices all across the country, a balloon goes up, the data comes back down, and forecasters glance at the numbers to confirm that yes, the atmosphere is doing roughly what they expected. Most days it is. Most days the numbers are about as surprising as your morning coffee tasting like coffee. This particular morning was different. The instrument picked up a reading for something called precipitable water. Basically, the total amount of water vapor hanging in the atmosphere above the launch site, expressed as how deep the liquid would be if you wrung every last drop of moisture out of the air column and let it puddle on the ground. For late May at Dulles, the 90th percentile for this measurement, the value you'd only beat one day in 10, sits around 1.4 inches. The 99th percentile, the value you'd only beat one day out of 100, sits around 1.6 inches. The balloon came back and reported 1.8 inches. Let that sink in. That's above the 99th percentile. That's not a May number. That's a mid-August number. The forecasters at the Baltimore, Washington office logged it matter-of-factly at 10 minutes after 10 in the morning, noted the moisture was expected to stick around, mentioned the Bermuda high pumping it northward, and moved on to the afternoon thunderstorm threat. No drama, no exclamation points. Scientists documenting what they see. But the number itself was the drama. 1.8 inches of precipitable water at Dulles on May 27th is the atmosphere lying about the calendar. It's the mid-Atlantic sky behaving like it's already deep into the sweaty, sticky heart of summer, 6 weeks ahead of schedule. And it wasn't just Dulles. Down in Miami, the South Florida forecasters were flagging precipitable water values that the GFS model had pegged at roughly 3 standard deviations above the seasonal average. 3 standard deviations. In a normal distribution of values, that puts the day in question in roughly the top 0.1% of all comparable days. Translated into something you can actually feel, the moisture the Florida Peninsula was about to experience was approximately a 1 in 700 event for the date. Not impossible, just extraordinarily unlikely. The kind of unlikely that makes a meteorologist raise an eyebrow. Meanwhile, on the other side of the country, Forecasters in the Los Angeles and Oxnard office were staring at an upper-level low spinning over the Sacramento area at a 500 millibar height of just 555 decameters. The seasonal average for that date and location sits somewhere around 580 to 585 decameters. That's 25 to 30 decameters below normal, an enormous anomaly. The forecasters didn't dance around it. They just wrote it plainly. This looks like January, and up in western North Dakota, the Bismarck office was issuing red flag fire weather warnings, afternoon humidity crashing to 15%, southeast winds gusting to 40 miles per hour, temperatures pushing into the lower to mid-90s. The Weather Prediction Center was forecasting that parts of eastern Montana and western North Dakota could crack 100 degrees by Tuesday. June 2nd, same planet, same week. California stuck in a cold winter pocket. North Dakota practically melting. The Gulf Coast soaking in tropical moisture. The Northeast bracing for a cool, damp stretch. Florida dealing with near-record moisture. A possible tropical system lurking in the Caribbean. How are all of these the same story? One forecaster in the Philadelphia office, in a morning discussion that almost nobody read, wrote a single sentence that explained the entire continent. He named the Omega Block setting up over the central contiguous U.S. That sentence is the key to everything. Part 2. What on earth is an Omega Block? The reason it's called an Omega Block is beautifully straightforward. When you draw the contours of the upper atmosphere across North America during one of these events, the pattern literally looks like the capital Greek letter O. There's a tall, rounded ridge of high pressure humping up through the middle, and on either side of it, two low-pressure areas dig down like drooping arms. The whole thing is horseshoe-shaped, or omega-shaped if you want to be fancy about it. The word block is in the name because that is exactly what it does. It blocks. While most upper-level weather features move steadily west to east, riding the westerly winds that circle the planet at middle latitudes, an Omega Block essentially plants its feet and refuses to budge. The ridge in the middle becomes a wall. The lows on either side get trapped. The whole setup can sit there for a week, 2 weeks, or, in rare and historically significant cases, 3 weeks or longer. And while it sits there, the weather underneath it stops behaving like normal weather. It becomes whatever the local position relative to the block dictates, and then it stays that way. The current. Omega Block parked over North America has 4 anchors. A Pacific upper low, spinning over California and the Great Basin. That's the January and May anomaly the LA office flagged. A central ridge, building over the northern plains and upper Midwest. That's the heat dome baking north. Dakota 3, an eastern trough digging down. Through the Great Lakes, dragging a cold front through the mid-Atlantic. That's why the Northeast is about to feel like mid-May when the calendar says June. 4. The Bermuda High, parked offshore to the southeast of the Carolinas. That's the moisture pump feeding the Gulf Coast and Southeast their extraordinary tropical-grade humidity. Carry those 4 pieces in your head, and every other weather story you hear over the next 2 weeks makes perfect sense. They're not 5 separate news stories. They're 5 faces on the same coin. Seriously, if this kind of connective tissue thinking about weather is hitting different for you, go hit like and subscribe. It genuinely helps the channel, and it means you'll be here when we break down what happens next with this system. Let me know in the comments, which of these 4 faces is hitting hardest where you live right now? Part 3. Why a block isn't just a really strong ridge. Here's something worth pausing on. Because a lot of people conflate an Omega Block with just a high-pressure system bringing nice weather. That's not what this is. Not even close. An ordinary ridge of high pressure is a visitor. It comes, brings a few warm, sunny days, and then the next weather system sweeps it off to the east. Maybe it sticks around 3 to 5 days at most. The weather is warm and dry, but the window is short enough that the consequences stay manageable. An omega block is a resident. It moves in and it does not leave. The ridge at the center acts as a wall that the normal west-to-east progression of weather systems simply cannot break through. And it sustains itself by feeding off the temperature gradient between polar air to the north and subtropical air to the south. The same gradient that powers the jet stream. As long as that gradient exists and the upstream wave pattern stays amplified, the block stays anchored. Most blocking events dissipate within 7 to 10 days. That's the typical case. A meaningful fraction persists for 10 to 14 days, which is where consequences start to compound. Drought intensifies. Heat stress builds toward dangerous levels. Fire weather sustains long enough to drive multiple major fires. A rare few persist for 2 to 3 weeks. The rare cases are the ones that earn names in the history books. The European heat wave of August. 2003 was anchored by a blocking event that sat over Western Europe for roughly 3 weeks. The death toll across the continent was estimated between 35,000 and 70,000 people. The Russian heat wave of summer 2010 was anchored by a blocking event that persisted over 6 weeks, with an estimated death toll of 55,000 or more. The Pacific Northwest heat dome of late June 2021 lasted only 5 to 7 days but reached extraordinary intensity, producing 121.3 degrees in Lytton, British Columbia, the highest temperature ever recorded anywhere in Canada. The European heat wave of July 2022 produced the United Kingdom's first ever 40 degrees reading at Coningsby, Lincolnshire, on July 19th of that year. Now, and this is important, the point here is not to suggest that what's happening right now is going to reach that level of catastrophe. The point is to give you a calibrated sense of what blocking events are capable of when they run long and deep. This current configuration, as of when this piece was written, is projected to last at least 7 to 10 days, firmly in the upper half of the historical persistence distribution, with possible extension into the second week of June. 10 to 14 days is enough time for consequences to stack up. There's one more thing to understand about blocking events before we walk through each regional face individually, and it's the detail that explains why these setups produce extreme weather rather than just persistent weather. When the jet stream gets stretched into a long wavelength configuration with sharp ridges and sharp troughs, the temperature gradients between the different air masses become very steep. Steep temperature gradients in the lower atmosphere are where storms form. They're where thunderstorm complexes organize, where flash floods happen, where the atmosphere concentrates its energy. A high-amplitude block doesn't produce calm, boring weather in the middle. It produces extreme heat at the ridge, extreme cold at the troughs, and violent, chaotic weather at the seams in between. That's why the current setup is showing 2 simultaneous slight risk, excessive rainfall zones from the Weather Prediction Center. 1 over the Gulf Coast and 1 over the Ohio Valley, separated by 700 miles. They're sitting on the edges of the central ridge, exactly where the temperature gradient is steepest. That's why the Storm Prediction Center has the Mid-Atlantic under a severe thunderstorm threat. That's why North Dakota is under a red flag warning at the same time that southern Utah is under a separate red flag warning for fire weather with afternoon humidity crashing to 8–10%. Every single one of those warnings is on the map for the same reason: the Omega Block. Part 4. 100 degrees in North Dakota. In May, the Bismarck Weather Service Office issued 2 products on the morning of May 27, 2026, and both of them were telling the same story. The first was a red flag warning covering 7 counties in far western North Dakota: Divide, Williams, McKenzie, Golden Valley, Billings, Slope, and Bowman, flagging the combination of afternoon temperatures climbing into the lower to mid-90s, relative humidity dropping as low as 15%, and southeast winds gusting to 40 miles per hour. The second was a hazardous weather outlook extending those concerns through Thursday and Friday. The language used, near critical to critical fire weather conditions, is not boilerplate filler. That's the language fire weather meteorologists use when they're telling land managers to prepare for potentially catastrophic multi-day fire growth. The Weather Prediction Center expanded the picture further, forecasting summer-like heat throughout the northern plains and upper Midwest, widespread highs in the 80s and 90s through the end of the work week, with eastern Montana and western North Dakota potentially hitting or exceeding 100-degree hours by Tuesday, June the 2nd. The public health language was direct. These early season temperatures could become hazardous to those who are heat sensitive, with widespread moderate to major heat risk across much of the central United States, and isolated extreme magenta-level heat risk possible on peak days. Just to put that in perspective, the 30-year climatological probability of a 100-degree weather reading at any western North Dakota first-order weather station in late May is in the bottom 3 to 4% of values for that date. Not impossible, just rare. 3 consecutive days of such readings? Less than half of 1% probability. And then consider International Falls, Minnesota, a town sitting on the northern border of the contiguous United States, practically on the Canadian line. A place affectionately known among local meteorologists for having 2 seasons, winter and road construction season. This is a city that regularly posts the coldest morning temperatures in the lower 48 during winter. The WPC forecast had International Falls approaching 90 degrees by the end of the week. Minneapolis, Fargo, Sioux Falls, Pierre, all of them running 10 to 15 degrees above their climatological norms. This is not normal. This is the Omega Block with its foot on the gas. The second-order consequence here, the one most likely to make headlines over the next 10 days, is fire. The northern plains have been part of a historic dry spring. And when you drop a high-amplitude ridge with 15% humidity afternoons and 40 mph wind gusts onto a landscape that's already bone dry after a record-setting dry January through March, you have all the ingredients for a catastrophic fire event. The Bismarck office's hazardous weather outlook extended fire weather concerns through Thursday and Friday. The Salt Lake City office's red flag warning for the Henry Mountains and Grand Staircase fire weather zones ran through Thursday evening. If you live in the northern plains or have people you care about there, the forecast for the next 10 days is not subtle. Heat well above seasonal norms, afternoon humidity in the teens, wind gusts of 25 to 40 mph, and critical fire weather conditions that could persist well into the weekend. Record high temperatures on June 2nd at multiple stations are distinctly possible. The orange and red heat risk bands are staying put, with magenta possible at the peak. Got family or friends in the Dakotas or Montana? Share this with them. This is the kind of pattern people underestimate because it builds gradually. Drop a comment if your area is already feeling the heat. I want to hear from you. Part 5. The Northeast Trades. June for May. While the plains roast, the northeastern United States spends the same stretch of days in air that feels like the calendar rolled backward. This is the second face of the Omega Block, the cool side. And it's the part that the New York City, Boston, and Philadelphia offices have all been writing into their forecast discussions without quite saying the unifying sentence out loud. The mechanism is mechanical and elegant. The eastern trough of the Omega has been digging down through the Great Lakes and the upper Ohio Valley, sweeping its associated surface cold front southeastward through the mid-Atlantic. Ahead of the front, the air is hot, humid, and unstable. The same air that gave Dulles its 1.8-inch precipitable water reading. Behind the front, coming around the backside of the eastern trough from Canada, the air is cool, dry, and stable. The seam between those two air masses is where the action is. On the leading edge, thunderstorms, potentially severe, with damaging wind gusts of 50 to 65 millimeters across the mid-Atlantic. Once the seam moves through, the Northeast settles into something that feels like a second mid-May rather than early June. Now, to be precise, this isn't a cold snap. Nobody's killing their tomato plants. New York and Boston are looking at daytime highs in the upper 60s to low 70s through Friday, with nights in the 50s. Pittsburgh specifically forecast at 73 degrees. These are not alarming temperatures by themselves. What makes them remarkable is the contrast. The same week that delivers 100 degrees to North Dakota delivers 70 degrees to Pittsburgh. Two cities sitting at nearly the same latitude, separated by approximately 25 to 30 degrees Fahrenheit on the same day. In early June, that's the kind of temperature gradient you'd expect in mid-March, when the polar jet is at its most restless. Not when the calendar is supposedly transitioning into summer. The block is holding that gradient open. The ridge in the middle locks the heat down to its west. The trough on the east locks the cool air down over the mid-Atlantic and northeast. And it stays that way for as long as the block holds. For people in the northeast, this is going to feel like a week or two of borrowed time. Cool, often cloudy, with multiple rounds of showers dropping south from Canada along the backside of the eastern trough. The first week of June east of the Mississippi is shaping up as a generally unsettled stretch. The Boston office flagged rain chances Thursday, with a likely period of rain arriving Friday afternoon and showers possible into the weekend with below-normal temperatures persisting. The New York office described multiple disturbances in northwest flow dropping south through the weekend, with the best chance for rain over the lower Hudson Valley and Long Island Friday night into Saturday. One specific note for anyone planning a beach day along the New York area coast. The pattern is keeping a moderate rip current risk elevated over the next several days, with 2-foot southeast swell and ongoing onshore winds around the backside of the trough. This is not a catastrophic hazard, but it's the exact setup that catches people off guard over Memorial Day weekend and the days that follow. Early June ocean conditions are not automatically safe, especially under this pattern. Two faces, same block. And the block isn't done. If you're finding this breakdown useful, hit subscribe. We're going to keep tracking this as it develops, and you don't want to miss the tropical part of the story coming up. Part 6. The West Coast woke up in January. Los Angeles and Oxnard forecast discussion on the morning of May 27th did something that operational forecasts rarely do. It compared the current weather to a different season entirely. Not a cool week for late May, not below normal for the date. The forecaster looked at the chart and wrote that conditions would be much more like Portland weather than Southern California weather. Clouds, periods of sunshine, breeze along the coasts and through the Antelope Valley. They were describing a 500 millibar height of 555 decameters over the Sacramento area. The seasonal average for that date and location is around 580 to 585 decameters, a departure of 25 to 30 decameters below normal at the end of May, when the upper atmosphere should be building towards summer values, is the atmospheric equivalent of waking up on the last day of spring, looking outside and seeing a January cold snap that didn't get the memo. The mechanism is the western leg of the omega. While the eastern trough traps cool air over the mid-Atlantic, the Pacific upper low parks itself over California and the Great Basin and does the same thing from the other direction. The central ridge between them, the spine of the omega, acts as a wall that keeps the Pacific low from moving eastward with the normal flow. So it sits and spins, and the air below it chills. The consequences on the ground are strikingly winter-like. Coastal and valley highs only in the 60s, running 3 to 6 degrees below normal along the coast, 8 to 12 degrees below normal in the valleys, and 15 to 20 degrees below normal in the mountains. Mountain snow falling at elevations that should have melted out weeks ago. The marine layer clinging to the coast like it's February. The Los Angeles basin running 10 degrees below seasonal norms day after day. The forecast does eventually show a gradual recovery, a slight warming trend beginning Friday as the upper low slowly moves out and a weak ridge nudges in, with coastal and valley temperatures returning to seasonal norms by Sunday or Monday, before a brief overshoot to slightly above normal early the following week as the ridge settles westward. Valley highs potentially reaching the mid-80s to lower 90s by that point. But the trajectory, January cold aloft, transitioning slowly back to seasonal values over the course of a week, is itself unusual. These kinds of spring cold troughs over California typically move through in 2 to 3 days. The fact that this one is sitting for a week is, again, the omega block doing what omega blocks do. The tropical part, what the data actually says about Arthur. So here's where we come back to the storm that doesn't exist yet, and might. There is no Arthur. We've established that. The National Hurricane Center's 7-day outlook at the time this was written explicitly states that tropical cyclone formation is not expected. That is not buried in the fine print. That is the official posture of the federal agency whose entire mission is watching for these storms. What does exist is a first significant tropical moisture surge of the 2026 Atlantic hurricane season being dragged northward from the western Caribbean into the southeastern United States by the southern leg of the omega block's flow pattern, the same Bermuda high and eastern trough configuration that is pumping three-standard-deviation moisture into Florida and delivering 1.8-inch precipitable water readings to Washington, D.C. is the same circulation that has been pulling deep tropical moisture northward out of the western Caribbean and the Bay of Campeche. And here's where it gets genuinely interesting. During the back half of the first 10 days of June, the same configuration that's currently holding the block in place is forecast to shift in a way that opens a corridor over the western Caribbean and Gulf, a corridor where 3 of the most respected ensemble modeling systems on the planet are flagging non-trivial probabilities of early-season tropical cyclone development. The pattern is in the data. The question is how it plays out. Whether those probabilities materialize into an actual named storm depends on a constellation of factors: sea surface temperatures, wind shear, moisture depth, the precise timing of the block's weakening that the models are still resolving. The ensemble guidance is not screaming certainty. It is flagging elevated probability. There's a meaningful difference between those two things, and the gap between what the data says and what the social media thumbnails are claiming is, right now, about as wide as it gets. The honest summary is this: there is no Arthur today. There is no Arthur tomorrow, and the National Hurricane Center says so in plain language. There is, however, a real and legitimately elevated probability of a named storm forming in the western Caribbean or Gulf corridor during the latter half of the first 10 days of June. That probability exists precisely because the same omega block that is baking North Dakota and chilling Pittsburgh is also reorganizing the steering currents over the Caribbean in a way that creates favorable conditions for early season cyclogenesis. Same block, fifth face.